in these four examples, example one, but these four tables, we're going to plot the points and determine from those scatter plots whether a linear, quadratic, or exponential model is most appropriate. So let's get started. This first one, we've got 0, 11. We'll plot that point, 0, 11. And then 2, 8.2. And then 4, 5. These are actual values from data that was collected. I don't know what data it represents, but these would be your actual data. So if you were doing an experiment, we could expect this to be actual data that you would find. Now this very much looks to me, we've got linear, quadratic, exponential. Linear obviously is looking like that, could be horizontal. Quadratic, we're looking at that U-shaped curve, either opening up or opening down. And then exponential, well, we know that we've got lots of different pictures that are exponential. So what I'm going to say is basically you've got a horizontal asymptote. Horizontal asymptote on one side and then increasing or decreasing. And then of course you've got your reflections in there as well. So this, I would say most definitely is a linear representation of some data. Let's look at the next one, -1, 2. So -1, 2, I'm going to do this in gray because I don't want to commit to a color yet. -1, 2, 1.5, 5.5, 4, 10.5. And then we're coming back down here, 6.5, 5.75. And then 9, 2.25. Yeah. Now, this is looking quadratic. I'm going to say that that is most definitely looking quadratic. I'm going to erase that sad example of a curve and say that this is quadratic. Now this would have, if this is going to be quadratic, there we go. We're going to have some residual value here. Residual value is when the point, now I can use orange, when the point is far away from the actual curve. So the points are your actual, and then the curve is the model. The curve is the model. So this one most definitely quadratic. Okay, the next 110, I'm going to try and catch up to 110. 3, 5.2, 5, 2.4, 7, 1.3, 9.7. This right here is most definitely modeling what? Yeah, this is most definitely modeling exponential decay. So we're going to call that exponential. Just exponential. You don't have to state whether it's growth or decay, but it's good to have that idea. And then this last one, let's see, -2, 2, 1, 3, 4, 4.5, 7, 6.75, 10, 10.25, 9, Now, as much as I want to say that it's none of the above, just to have one of each, this is exponential. It's not exponential decay, it is exponential growth. But whether it's growth or decay, both of these, C and D, are exponential. Now, in the next video, we're going to talk about residuals. Next video, we will talk about residuals. And I know that you might have heard this before. You might have even heard it in this class before. But we'll go into it just a little bit more deeply when it comes to the graphs and its role in determining whether or not the model that you select is a valid model.